Now, this unit will have a lot of crossover with Science 10, particularly the physics part of it. 142. So, if you've already done Science 10, you're going to have you'll be very comfortable with this unit. If you haven't done Science 10 yet, or you haven't done the physics part of Science 10 yet, this will help you with that. If you're doing them both right around now, then you're going to get double reinforcement from two different classes. So, let us begin cabbages. 3 words there. I'm going to be using these words a lot. You're going to need to know what they are. The first one is set. Now, you all know when I say the word set, you have all seen this because it's been stolen from math by English. Right? The Venn diagram, how you put all the qualities of something here, all the qualities of the other thing here, and everywhere they overlap is things that are shared between them. Right. That's been stolen by English. That's fine. We don't care. We share. But that's what we were talking about here. This is a set, and this is a set. And then this is a third set. So a set, in much simpler terms, is anything that we can count. Okay? We also use the word data. So in this classroom right now, we could make hundreds of sets of data. Yes? The easiest set of data, I would say, in this class would be how many people were in it. Everybody with me? That's a single set, because I can count every person in the room. Yeah? Everybody good? It's easy. Okay. So, anything you can count. So I'm going to start that off with people in here. In here. In here. Hey! All right, so that's the set. Next word, an element. A single item in the set. Or, to use this word again, a datum. Data is plural, datum is singular. So, if the set is people in the room, give me an element of the set. Exactly. Evan is an element of the set. Now, this is when somebody usually makes a joke about, are we sure we want to call Evan a person? Right, Evan? Yeah. Zaro, go down to the second floor and write this test. Second floor, straight down the stairs, through the door where it says the big open sign. And stop missing my tests. Everybody good? Okay. And finally, the fourth, or the third word is a relation, is anytime we compare two different sets. So, in this room, there's a set of people. Agreed? That set of people is made up of elements, all of us. In the room next to us, is there another set of people? Yes. It is also made up of elements. Yes? In that room, there are elements that relate to elements in this room. For example, in the room next door, there are students. In this room, there are students. Agreed? In that room, there is a teacher. In this room, there is a teacher. Right? I don't think there's an EA in the next room, which means Miss Lloyd could be in her own, very own set with no relation in the next set. Does everybody understand? Everybody good? Okay. So now we can carry on with this. Here I have a graph. It is a bar graph. You've seen bar graphs like this many, 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 many times. You cannot make a graph without having a relation between two sets. Okay? What are the two sets in this relation? Talk to your neighbor if you need to. You know what the definitions are. What are they? Michael. Dogs and height. Does everybody understand? Types of dog would be fine. Something like that. One of the sets is the types of dog. One of the sets are the heights. Is everybody good with that? Pardon me? I'm sorry?
Every bar is a set and it's the entire graph together.
No. The sets are here and here. The yellow and the blue. The relation is when I compare the two. Okay? So, what is the first element of the set of dogs? What would you say is the first one you would read? Hound, because it's on the left, right? So, set one, which we said was dog type. And you would say the first piece of evidence there was a hound. Yes? Does everyone agree? Okay. Is it a relation yet? No, why not? Because I only got one thing. I've only got one element. It's not compared to anything, right? Okay. What is set 2? No. The set is dog type. The element is hound. What is the other set? Heights. Now, what is the first height you see? 60. Excellent. So now we have a relation, which I'm doing in green because it's yellow and blue mixed together. Is everybody with me? I have hound. That's one element in one set, and that compares to the element 60 in the other set. Is everybody cool? Everyone's cool? All right, now list the elements in set 1. So set 1 we decided was the dogs. What's the next element in it? Which I hate to say because they aren't really dogs and should go away. And next? Corgi. Everyone's favorite dog, not really, but favorite dog of the queen. Then lab. Then shepherd. And if you mix those two dogs, you get the greatest dog in the world. This guy.
Oh, what is that?
That's my dog. And then Malamute, which is a giant husky.
So the referencing bears?
Huh? Everybody good? Mm-hmm. Okay. Now, what are the elements in the second set? You're going to say 12. Okay, that's cool. 30. Then what? 45. Then what? 45. Then what? 80. And now we have two sets that have given us a relation, right? If I ask you how tall is the hound, you can tell me because we have made this relation. Is everybody good? Is everybody good?
Yes.
80.
If you're comparing two elements instead of sets, do those elements count as sets on their own, even though there's one of them?
If you're comparing two elements from the same set,
Okay. So comparing sets would be comparing this class to another class, right?
Yep.
If you were just comparing one person from this class to one person,
then that's a relation.
that's still a relation. But
Yes.
does it count as relations of elements, or do those each in separate people become their own forms of set of a set because they're still being compared, even though there's only one of them? Can one thing?
Okay. Let me change the scenario. Everybody leaves the room except you, and everybody next door leaves the room except John. Okay? Then your set now only has one element in it, you. That set only has one element in it, John.
But it's still a set.
They're both still a set. A set can have nothing in it. It can have some in it, or it can have thousands in it. Okay? Let me give you an example of an empty set. In this room, are there any movie stars? No. So that's an empty set. Is movie stars an element? Are there movie stars in the world? Yes, but there are none in this room, so it is an empty set. If The Rock walked through that door, first of all, we would all be like, we're not doing math ever again. Because I would be too busy going, hello, Mr. Johnson, because I love The Rock. But he would be in his own set, even though he was a member, an element of the set of people in the room. Do you understand? You can make the set smaller, but they're all still an element of the larger set. I think I helped.
Yeah.
Okay. It's kind of like natural numbers and whole numbers, right? Whole numbers are a set. Natural numbers are a slightly smaller set, but everything that's a natural number is a whole number as well. Okay. So is everybody good here? These are related, yes? If I say hound, you know how tall the dog is, right? If I say chihuahua, you know how tall the dog is, right? If I say I have a dog that's 80 centimeters tall, do you know what kind of dog it is? Yes, what kind? Malamute. Everybody cool?
At what point does it say the numbers are necessarily centimeters?
It may not, which would be my fault. That's an error. A 90-inch tall dog would be 7.5 feet. I don't want to meet any dogs that are 7.5 feet tall.
I'm really bad at being different.
But you make a valid point. This graph is missing a very important piece of information, isn't it?
A reference.
It's missing its scale,
There we go.
right?
It's called.
Its unit. It has its scale, but it's missing its units. Because are we talking about Genectogazoinks here? Are we talking about Hoofenblattens?
Light years.
Right. So, good point. A good graph also has units when needed.
I did once see a dog in Costco that's sitting down with his tall
So-
shoulders. So
You're ahead of where I want to be. That's weird. You're ahead of where I want to be, but since you've brought it up and a good teacher goes with what happens in class, I will tell you now that graphs need 4 things. They need a title. They need axis labeled and the other axis labeled. So this is not labeled. It's just got a bunch of names. We should have said type of dog, right? This should have said height. And they need scales if necessary. Not scales, units if necessary. So if I said average dog height in centimeters at the top, would I need to put centimeters over here?
Yeah. I think so.
If I had it in the title, I wouldn't.
Oh, no.
Okay, because I've already labeled the height. So that was supposed to be coming later, but since Aiden brought it up, I'll take care of it right now. Everybody is good? All right. Now, all of you should see a problem with everything I've been saying. What dog is 60? Hound. Great. How tall is a corgi? A corgi. How tall is a corgi? 30 centimeters. Excellent. I am thinking of a dog that is 45 centimeters tall. What dog am I thinking of?
Labrador.
No. I'm not. No.
Your dog.
No. No.
hounds cross with corgis.
No. Does everybody understand why I'm saying sticking at 45? Why did I do that?
There's 2.
Because there's 2.
And you can change your answer
When I say 45, you do not know of which dog I am speaking, do you? So we have a relation because every dog has a height, yes? Right? There's no dog that isn't there. Every dog has a height. So this is a relation. But because you do not know of which dog I speak, we can only call it a relation. Do you understand? Because when I say lab and shepherd, both of them could be 45. That means this is only a relation. Everybody cool with that? All right, now turn the page over and you see our fourth new word. Our fourth new word is function. And a function is a specific type of relation. So it's still a relation. It's got two sets that are being compared, but it's a specific type of relation whereby each element relates to a unique element in the other set. In the other set. Okay? So, I will remind you we had hound 60, Chihuahua 12, I think we said, Corgi 30, Lab 45, Shepherd 45, Malamute 80, right? That's a relation. The problem, the reason that it is not a function is because Lab and Shepherd both related to 45. It was not unique. Does everybody understand? So right now, the dogs versus height, right now it's a relation. Because if I say a dog, lab, you know it's 45. But if I reverse it and I say 45, you do not know which dog I am speaking of. Is everybody cool? That's what makes it a relation. But if I do this, if I remove the lab, then I have what's called a function. Because everyone is its own pair. Is everybody with me? If I say hound, you say 60. If I say lab, you say 45. If I reverse it, I say 45, or we remove the lab. If I say 45, you automatically say shepherd, and you know. Is everybody cool? So, remember, all functions are relations. But not all relations are functions. Everybody cool? All right. Talk to your neighbor, think about it yourself. I don't care how you think about the next three questions, but we're going to talk about it. I want to know, in number one, the sets, what sets the scenario is speaking of, and I want to know if it's a function, and I want you to explain it. Okay? So we're just going to do number one right now. Talk to your neighbor, think about it. What are the two sets involved in number one? The two sets of data. All right. What's the first set?
Month of the year.
Months of the year. Right? How many elements are there in that set? 12. Excellent. January, February, March, so on, so on, so on. So set 1 is months. And let's put a few elements. January, February, March, April. Everybody cool? It would go on, but we're out of room. Everybody good? Okay. What is set 2?
Number of days.
Numbers of days. What are my options?
13 and 31.
31, 30,
29.
29,
28.
and 28. Everyone agree? I have 2 sets now, yes? Now, is it a relation or is it a function? Well, let's check. Both relations and functions compare 2 sets of data, yes? So let's compare them. January, oops, I wanted to change color there, you piece of junk. January compares to 31. Right now, is that a function or is it a relation? It is a relation because I'm comparing 2 sets of data. Is it also a function? Yes, because they're unique, aren't they? Nobody else has 31. Everybody agree? Okay. February.
28.
28 or
29.
29. Is that a relation or a function now? This is a tricky one. It's still a function because 28 or 29 can only be February, right? Okay. What about March? 31. Now, is it a function or a relation? It's a relation. Why? Because there's 2 31s. If I say 31, you do not know what month I'm speaking of. Does everybody understand? I can name any month and you know what month I'm speaking of, right? But if I go backwards, you don't. Everybody cool? So that guy is a relation because of January hits 31, March hits 31. Right? Or April and September are both 30. Everybody good? All right. Let's go to the next one. Every name on my class list relates to a student in my class. What is set 1 and what is set 2? So set 1 is my list. Okay? So set 1 is my list. Set 2? The names are on the list. Set 2 are the actual students. Agreed? So, is this a function or a relation? We know it's a relation because everything's a relation once we compare 2 things, right? Is it a function? Just to show you, I'm just going to do something here. Just give me a sec. Oh, actually, I don't need to do that. Come on. I'm trying to bring up my class list so you guys can see it. There it is. There's my list. Some people aren't in the class anymore, but this will do anyway.
I'm starting to understand why some of the teachers have difficulties pronouncing some of the names.
Yes. All right. There's a name. Zorro, right? How many Zorros are in the room? 1. Function or relation? Function. If I say, he's not here, that kid's name, you all know Zorro. And if I say, where's Zorro? He's that kid that sits right there. Everybody agree? Is everybody good? All right. Go down that list. Are we okay? Thank you.
But you took the last name.
I'm getting to that. Okay? So, Schumacher caught it. You're not supposed to see that.
Was that everyone's marks?
No, it was homework checks. So, on the list, if I go by, now here somebody always says, okay, you've got a list. That list has first names and last names on it, yes? If I go by first name only, is it a relation or a function? It's a relation, because we've got two Michaels, don't we? I'm thinking of a Michael. Which one? You have no idea, right? Okay. If we go by first name, it's a relation. If we go by last name, are we okay?
No, because we have siblings.
In this, no, not on my class list. They would have to be twins, right? Well, not necessarily twins, but there would have to be some jiggery-pokery in grading to get them in the same room, right? Now, in my Block D class, I have the Holloway brothers. So, by first name, I'm okay. But by last name, I'm not. Because they're both Holloways.
What if you go by both?
If I go by both, I'm 99% of the time, it's going to be a function, yes? Except in your people's grade 10 class, because there are two Jasreet K. Dillons. They even have the same middle name.
Wow.
Which has never happened to me before. It's this a very good year to be teaching functions this year. Because every kid always says, well, if you go by first and last name, it's always going to be a function. Ha-ha!
It just takes all
It will not be.
the points.
My homeroom is not a function in any way. Because I have two Jasreet K. Dillons.
I remember.
Everybody with me? So last name is a function. And then first and last name is also a function. Does everybody understand? Are we all good with what defines a function and a relation? Okay. Now, more new words. Dependent variable, independent variable. If you were in my grade 9 class, you already know these. Some of you might know them from science. How many of you have seen these terms? Crap. Okay, no problem at all. We're going to be just fine. We will start with the dependent variable, which I abbreviate in a very cunning and original fashion as dv. Okay? What does the word dependent mean in English? You depend on something else, yes? You people are dependents, right? You don't pay for your own housing, you don't pay for your own food, you don't pay for your own clothes, you don't pay for your own cars. Well, some of you might pay for your own cars. But you people are dependent. Agreed? Okay, Michael.
Could it be like, I see acid companies, hydrogen carbon,
Yes.
that I've heard about it.
Okay. That's a good example. I wouldn't call one of them a dependent variable, but you're on the right track. So everybody understands what dependent means, yes? What does variable mean? What does the word variable mean in English? Nobody? Changing. It changes, right? So our dependent variable is something that changes. But because it's dependent, can it change by itself? No. Something else has to change before we change our dependent variables. Everybody cool with that? Okay. So our dependent variable, and this is one of those times I have to do that horrible, horrible thing where you use the word in the definition. And I hate to do it, but you really have to. The dependent variable is a value which can only make sense when compared to another value. So let me give you an example. 32. Does that mean anything to any of you? It's a number. 32 applies to some of you in this room. Do you know what I am speaking of? Number of what? I am not that mean, Mr. Schumacher. You don't know, right? We could guess a million things, couldn't we? Because that would be a dependent variable. Everybody cool? Okay, so it only makes sense when it's compared to another value. Obviously, the independent variable, the IV, is a value that can stand alone. I like to say that the independent variable is the one everybody can see or share. So let me give you an example of this. Right now, I'm thinking of a kid in this room. Do you know what it is? Do you know who that kid is? No, you do not. So it's variable, right? It could be any kid in this room. Agreed? But as soon as I say I'm thinking of Max, we all know what Max is, right? Everybody good? Now, I'm going to add this to it. Max, and I'm going to relate that to another data, 30. Do you know what I'm speaking of? Now I am going to give another variable, Aiden. And Aiden, I'm going to say 34. Still don't know, right? No, because I didn't give you a scale. I am guessing it is the length of their jeans if they were to buy pants. That is my guess. Everybody understand? The length of jean depends on the kid I am speaking of. Yes? Right? If I say 30, that usually means somebody who's a little bit short, like myself. If I said 36, that would be a tall, long-legged character, like Evan. Everybody understand? The length of jean depends on the kid I am speaking of. But the kid is still the kid. Whether they're wearing jeans, shorts, a wetsuit, it doesn't matter. Does everybody understand? Does everybody understand? Everyone's good? Okay. So now we need to talk because these guys compare to these guys. So I'm draw an arrow. The dependent variable is the range. Okay? The range is the entire set of elements that make up the dependent variable. It'll show up in a second. So in that example I just gave, kids and length of jeans. Length of jeans is the dependent variable because what kid I say will define the length of their jeans. Everybody understand? So the range is all of those jean lengths. Everybody good? Then obviously, the independent variable is the entire set of, or the domain is the entire set of independent variable. Is everybody good? Yeah? All right, now, over on the side here, 99% of the time, the x-axis is the domain, which is the IV. And the y-axis is the range, and that's where we put the dv. Does everyone understand? So, don't draw this, I'm just going to show you. If I was making a graph, I'd have your names down here. Max, Aiden, Myers, 3 people in the room, yes? Max, you know how long your jeans are? we'll say they're 30. Right? So that would be max 30. Right? Independent variable because it's on the x-axis. Dependent variable, it's on the y-axis, xy. Just like grade 9, right? Aiden, he's taller. Aiden's going to be 34. So he would be Aiden, 34. Myers, I've got little tiny stubby legs. 30. Everybody cool? Everybody good? That's what the graph would look like. Is this a relation or a function? Why? Because 30 is twice. I'm thinking of somebody in the room with 30-inch jeans. You don't know who I'm thinking of, right? Okay, good. This is the key piece right here. Just because we usually graph it that way doesn't mean we always graph it that way. You still need to know the definitions of which is which. Everybody cool? Okay. Turn the page over. Sandy is getting a job at Flying Wedge Pizza. She's paid $9.50 an hour. Her hours worked are related with her pay per week. Yes? Okay. You can tell how old the notes are because it has minimum wage below $10, but we'll leave it at that. So, what is the independent and the dependent variable? Talk to your neighbor. What is the IV and what is the DV? You got a 50-50 shot if you haven't been paying attention. But if you've been paying attention, it's not too hard to figure out. Right. Hours is independent and pay is dependent. Why? But I could turn that graph sideways.
Yeah, but for the number of hours, if you're not getting paid anything,
There you go. This is the definition I need.
then you're still working. It just doesn't pay how much you're getting.
If I don't go, if Sandy doesn't go in and make pizzas, is she going to get paid? No. So her pay depends on the hours she is at Flying Wedge. Does everybody understand that? If she doesn't go to work, do those hours still pass for her? Do those hours pass for you? Do those hours pass for everyone? That's why it is independent. Does everybody understand? Because no matter who we're talking about, those hours are still passing. But if you are an employee of Flying Wedge and you are at Flying Wedge, when those hours pass, you get paid. Everybody with me? Excellent. So we now know the independent variable and we now know the dependent variable. Now I want to know the domain and range. The domain works with which one? The IV or the DV? Right. The domain is the set of independent variables, right? So what's the lowest amount of time she could work in a week? 0. Maybe she doesn't work that week. So the domain, the lowest value is 0, yes? What is the most she could work in a week and still get paid $9.50 an hour? Do you guys know this? In a week. 40. Yeah. Everybody cool? Because that's when you start getting paid overtime, which is more than $9.50. We'll talk about that in another class. If you work 0 to 40 hours a week, you get paid your wage. Is everybody cool? So the range has to be from 0 up to what? 40. Everyone understand? Now, technically, it would go down to the second, wouldn't it? But they don't schedule you for work that way. You guys have jobs. You're scheduled maybe down to what? A 15-minute? If you have a job? Everybody cool? Now, we write this in a special way. There's two ways we can write this. I'm going to teach you one of them right now. You make these little squiggly brackets that look like devil horns in old emoticons. It's this bracket. Down, arrow, down like that. I just draw a squiggle because I'm bad at drawing those small. Then you put your lowest value first. Okay? And since that is the lowest value I could have, 0 is less than or equal to my hours. Right? Because I can't go lower than 0. But my hours are less than or equal to what? What's the most hours I could have? 40. And then we do another squiggly bracket. Everybody cool? Yeah, it is. Set theory is a big part of code. Is everybody good here? Okay. What then is the range, which I'm going to draw in blue? What's the lowest amount of money she could earn? 0. Now this one's tricky. Because she could work any amount of hours between 0 and 40, can't she? Right? She could work 1, 2, 3, 4. Right? Can her pay be any value? What's the lowest amount she could make? 0. She goes in for 0 hours, she gets paid 0 money. If she goes in for 1 hour, how much she get paid? $9.50. If I tell you she only works in full hour increments, could she ever be paid less than $9.50? No. So can I write it this way? No. Because it can only be $9.50 or $19 or $27.50. Does everybody understand? So her range, we would have to write out each separate amount of money. Does everybody get why? Pardon me? $28.50. Thank you. No, that's fine. Does everybody understand? She's paid per hour. She can work 0 to 40. Right? Everybody cool? Now, is it a function? Yes or no? If I tell you she was paid $95, do you know how many hours she worked? It's a function. Yeah, why?
Because there's no hours that overlap.
Right. Every hour gives a unique pay. Right? Soon as that hour changes, we go to a new pay. Everybody with me? So this is a function. Because each independent variable IV gives a unique DV. Everybody cool? Now, I want to call your attention back to something. You guys think back to like grade 6. Think back to your textbooks. Most of you will have seen something that looks like this. You remember seeing anything that looked like that? They drew it like a machine. And you would drop in a number. 5. 5 would go in, input, and then we would add 7 to get what? 12. Then we would take away 3 to get what? 9. Then we would multiply by 2 to get what? 18. And that became our output. Do any of you remember seeing a drawing like that in like grade 5 or 6 in your textbook? Some are shaking their heads yes, some are shaking their heads no. It just depends on who your teacher was.
Something similar but very different in how she showed it.
Yeah. The teachers that I had, and some of you had if they were old, they would have been young when I was a kid and old when you were a kid. This is called the function machine. and you put in your input, whatever number you had, you did all the math, and you got an output, right? This was your independent variable. This was your dependent variable, because your output depended on what you did to it. Does everybody understand? All right. So look at number 4. Believe me, you know how to do this. I've given you all the hints you need to figure this out. When you see two numbers written this way, what are they? When you see 1, 3, you got to think back to grade 9. What is 1, 3? What is it, Evan? Yeah, it's the x's and y's, aren't they? So that's x, that's y. So that's xy, 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 xy. We've already talked about x's and y's, haven't we? X's are what? Our independent variable, right? Or our input. Y's are our dependent variable and our output, right? So, which of them, x's or y's, is the domain? It's right on this. X's are the domain. So, let's write out our set of the domain. Remember, when we're writing out a set, we got to use the squiggly brackets. So what is our lowest domain value?
0.
No. 1. 1. What's next?
2,
What's next?
3,
What's next? And that's our domain. What's our range that I write in blue? 3, 6, 9, 12. Is it a function? Yes or no?
yes,
Every x gives me its own y, so it's a function. Everybody agree? Great, do the next one. What is my domain in red? 1, 0, negative 1. Even though I've got 2 zeros, it's only one value, right? What's my range? 0, 1, negative 1, correct? Now, 1 gets 0 and nothing else, right? So it's a function so far, isn't it? 0 gets what? 1 and negative 1. So is it a function or relation?
relation,
This one is a relation because IV of 0 gives 2 dependent variables. Everybody understand? Because 0 as an input has 2 different outputs, we're screwed. Everybody cool? I don't find this concept to be particularly difficult, but nobody seems to be agreeing or disagreeing. Do you all understand?
Yeah.
Because my independent variable of 0 gave me 2 dependent variables, it's not a function. Just like back in the beginning, yes? Hounds, or shepherds and lambs, right? When I said shepherd, I had 2 different heights. What about this one? What's our domain? 2, 4, 6, 8. What's our range? 3, 5, 7, 9. Function or relation? Function. Because 2 goes with 3, 4 with 5, 6 with 7, 8 with 9. They're all unique. What's different in D? It's on a graph. What are graphs made of? X's and Y's, right? So, the domain are the X's, correct? So I only care about the X's, right? This line right here, yeah? I have an X there, don't I? What is that value? -3. I have an X there, yes? What's its value? -2. What's next? There isn't one at -1. The next one is 0. Then what? 1. Then what? 2. Then what? 3. Can everybody figure that out for domain? On domain, we look on the x-axis. Where do we look on the y-axis? Where do we look for range? On the y-axis. Is there one here? What is it? -3. Is there one here? What is it? -2. What's the next one? -1. Is there a 0? Is there a 1? And? And a 2. Do I have a relation? Am I comparing X's and Y's? Yes. Do I have a function? Why not? What happens at X equals -2? What are my Y values? -1 and -3. Does everybody understand? At that X value, I had 2 Y values. -1 and -3. So no good. Everybody cool? Yes.
But we still wouldn't have known which.
But you wouldn't have known which dot I was speaking of if I said, I'm thinking of an X value of -2. What's the Y value?
That's true, but that would have gotten the question of whether it was a function or not.
I'm sorry?
That would have gotten the question of whether it was a function or not right off the bat. Because it's not a function.
Yes, it's not a function because of what we're just saying. There's 2 Y values at that X value.
And that's why I was saying you could have just written 2
Yeah. Yes, if I wrote the ordered pairs, that's what would have happened. But this is not ordered pairs, is it? This is just the X values and just the Y values. But if I had written it as Michael is saying like this, -3, 2, -2, -1, -2, -3, as soon as you saw 2 inputs, or the same input with 2 different outputs, you know it's not a function. Everybody cool? Now,
What
the
if they were the same input and output?
I'm sorry?
Like, what if there was 2 dots in the same place somehow?
Then it's not a function. Because for that input, you would get 2 outputs. Now, the vertical line test only works on graphs. And it works like this. A vertical line can only touch the graph once in a function. And here's what I mean. There's a graph, yes? It's got X's down here. It's got Y's up here, yes? If I take a vertical line Please notice that anywhere I draw a vertical line, how many times does it hit the graph? Once. So whatever value of x I have, I'm only going to have one y value. Does everybody understand? This is a function. Now, if I change it slightly to this, what happens as I take that vertical line and I move it along? Am I okay? Function, 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 function. What happens right there? At that x value of 10, I have 1, 2, 3 y values, which makes this a relation. Does everybody understand? It only works on graphs. Cool? And we are almost done, and I'm giving you no homework tonight, so don't worry. Look at number 5, and just tell me if it's a function or not. No. It's graphed, so we can use the vertical line test. Why not? Because I do ask you to explain why. Why is it not a function? Right. So I check my vertical line, blah, blah, blah. But as soon as I hit my vertical line right here, I hit 2 different values. So it's a relation. Everybody good? Yeah. Okay. So we know it's a relation because at x equals -1, there's 2 y values. Does it happen any other time? When does it happen again?
1.
Right. And at x equals 1, there's 2 y values. Great. Everybody's good at that. Now, this is the hard part with this section of this unit. What is the domain and what is the range? The domain is the set of independent variables. The independent variables are on which axis? X. So I'm only caring about x's, correct? What is the lowest x value? -3. What's next? -2. What's next? -1. Then what? 0. Then what? 1, 2, 3. Now, what's the range? Everything on the y. Where do I start? The lowest or the highest? The lowest, which is what? -2. -1. 0. 1, 2, 3. Please notice that there is no point at -3, -2. This is not pairs, are they? They're just lists. Everybody good? All right. B. What is it a function? Yes or no?
Yes.
Take my line. And it's a function y. Because it only hits once, yes? So we know it's a function. Now, something weird is going to happen here. It's a function because every x has one y value. So we know it's a function. How is the domain and range different here? What is the low? Where do I look for domain? On the x-axis. So what is that value right there? -3. Agreed? Now, since this is a solid line, isn't every single possible x value on that line?
Yeah.
Is negative 2.9 on that line? Is negative 2.1 on that line? Is negative 1.73 on that line? It is, right? So I cannot list it like this, can I? Because how far is it from negative 3 to negative 2? Yeah. How far is it from negative 3 to negative 2? How many numbers are between negative 3 and negative 2? Infinity. So we cannot list them, can we? So remember that other way I showed you to write these? What's the lowest value? Negative 3. That is lower or equal to x. Right? And x is lower or equal to what value? 3. Does everybody understand? Okay. Now we do the same thing with the y value. What's the lowest y value? Negative 2. Right? 1, 2. Agreed? Does it go up all the way? To what? To the highest y value. Not here, but up there. So what's our range? Negative 2 less than or equal to what? Y, which is less than or equal to what? 3. Does everybody understand? We're going to do a ton of these. Everybody's cool? And I'm going to give you a shorter way to write this because this is cumbersome. This is what we call set notation. Because we write it with the squiggly brackets. Everybody good? Look at C. Tell me what's the same. What's the same in C as in B? It's a function. And it's lines, correct? But what's different?
Lines are separate.
They're separate. So this guy has a domain and range, and this guy has a domain and range, doesn't it? You got to label them. What is this guy's domain? Look closely. It's very tricky. Negative 30 less than or equal to x less than what? Where does the first domain stop? Negative 10. Why do I have less than or equal to and less than? You have to remember grade 9 to do this. Why do I have two different signs there?
Because the line ends just before.
The line, there's an open dot there. Do you all remember that from grade 9?
No.
When you had to do x plus 2 is less than 7. And then you had to put it on a line. Because that's x is less than 5. So you had to circle it and put a line there. But if it was equal to 7, then it could have been 5 and you colored it in. You should have done that in grade 9. If you were in my class, you did. So that's why that's not equal, because it's an open circle. Now, what is this guy's domain? What's the lowest one on the second line? 0. Do I hit 0? Is it a colored in dot or an open dot? Colored in, so that means I hit 0, so it's equal. Do I hit 30? No, so it's just a regular arrow for 30. Now I have two sets, right? So I have to put a big U in the middle of it, which stands for union. That set and that set. Everybody cool? Now you do the range. What's my lowest range here? Negative 20. What does it go? Do I hit negative 20? Yes or no? Is it an open or a closed dot at negative 20? This is not a difficult question. Closed. So I hit negative 20, so it's equal. Do I hit 0? No. So it's the regular arrow. Then it starts again with a big U. What's my lowest one up here? There's where it starts again. It goes there to there. Then it starts again at 10. Do I hit 10? No. So it's a regular line. Up to what? 30. Do I hit 30?
Yes.
So I have to have the equals. Is everybody cool? Yeah? Okay. Now I'm going to give you the other way we write this. The lowest range is negative 30. So we put a square bracket beside it. The highest domain is negative 10, but we don't hit it, so we put a round bracket. Union. What would this one be? Square or round bracket first? Square, because we actually hit 0, and we go up to what? 30 with what kind of bracket? Round, because we don't hit 30. What is it in domain? What's the lowest domain value? Minus 20, up to what? 0 first. Do I hit 20?
Yes.
So what kind of bracket?
Squared.
Square. Do I hit 0?
No.
So what kind of bracket?
Round.
Round. Do I hit 10?
No.
No. Round. 10. Do I hit 30?
Yes.
Square. And this is called interval notation. But this only works with lines. You can't use it if you don't have a line on the graph. So, would it work for this one? Could I use interval notation here?
No.
No, because it's dots.
Oh.
Could I use interval notation here?
Yeah.
Yes, because it's a line. Everybody cool?
Oh,
Okay. So it's the last thing we're going to do. We got 8 minutes, and I'm giving you the rest of the morning off. And I'm not giving you any work for tonight. The domain is the x value. What's the lowest x value on this line?
-4. Or -5.
Negative.
It's right here. What is it?
-4.
Negative 6.
-6. Open or closed dot? Open. So it has to be that arrow, yes? Or -6 with a round bracket, right? What's the highest x value?
-6.
6. Do I make it to 6? Is it a closed or an open dot at 6? Closed, so I make it to 6, yes? So, what kind of bracket here? Square. Everybody cool? Okay. Now notice, since my domain made a line, I was able to use interval. Everybody see that? Okay, let's do range. What are my range values? What's my lowest y value?
3.
Right there, 3. Then what? Right there, what is it?
9.
6. Then what?
9.
9. Did I make a line?
No.
So can I use either of these? I can't, can I? Because I didn't make a line. It's only 3, 6, and 9. So I have to do that. Does everybody see the difference? If I make the line, I can use these two. If I have dots, I have to list them. Last question, then we're done for the day. Is D a function? Yes or no? Oops, that's the wrong color. Here is my vertical line.
Yeah.
Yes.
Is D a function?
Yes, it is.
Yes, 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 yes.
Because it possibly stretches past there.
Why aren't I hitting the line twice there?
Yeah.
But I'm not really, am I? Because does that dot exist?
No.
No. So it's okay. What if that one was solid?
Then it was.
Now what is it?
Relation.
Relation. Does everybody understand?
Isn't that further ahead, or is it less?
Pardon me?
The open-ended dot, does that mean it'll stretch further?
That means it starts again at negative 2.999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999. Okay? Well, yes or no, Aiden? Okay. I'm going to stop recording because